Okay, so today we are starting rhombi, or rhombuses. When we have a rhombi, it's kind of like a square almost. So in my rhombi, I've got these two right angles right here, which means, because they are vertical angles, if one side is 90, the other side has to be 90. I've also got some more points of congruency. These two pieces are going to be the same. These two pieces are going to be the same. Now, I said it was kind of like a square, and I said that because all of my sides, my outer sides, are going to be congruent. My diagonals, depending on the diagonal, are congruent. Now, because it's tilted, think back kind of like with a parallelogram. This piece, top and bottom, or horizontal, are going to be parallel. And my two side pieces are also going to be parallel to each other. When I'm looking at angles, these two angles at the bottom and these two angles at the top right are going to be the same. So all four of those angles, identical. Same kind of process goes on the other side. All four of those angles, congruent, identical. Now, like with a parallelogram or a rectangle, these two pairs of angles, this top one up here, this bottom one down here, are going to add to equal 180 degrees. Now, if you would flip to the web, we can get all the parts written that go with that. So in my web, make sure you can see it. In my web, I've got opposite sides are parallel. I'm going to shorthand for some of these. I've also got opposite sides are congruent. I've got opposite angles congruent. I've got consecutive, that means same side. Angles are supplementary, or 180 degrees. I've got my diagonal bisecting each other. Oops, diagonal, bisect. Ran out of space, but that's okay. These were the same as a parallelogram, and these were the beginning parts of a rectangle. Now here's the parts that are a little bit different. All of the sides are congruent. My diagonals are bisecting the angles. It means they're cutting them in half. That's why those angles are the same in those spots. And all of my diagonals are perpendicular. Because they are perpendicular, that's where you get that 90 degrees from. Okay, now we are going to flip to page 13. We filled in our graphic organizer already, so now we're just going to kind of go through and solve this. So I'm going to label the pieces that it's given me. It's given me JK and JN. JK was 12, JN was 7. We're going to start with the easiest. In a rhombus, all of my sides are congruent, so that means this is 12, and this is 12, and that is 12. Also, whatever line is bisecting, the same is on the top as on the bottom. So JL is my line that's being bisected, right, by this line. If 7 is there on the top, 7 is there on the bottom. So now let's look and see what it's asking and see if it's any of this information we've already filled out. It wants JM, well that's this side over here, I know that's 12. It wants JL, that is that whole bisector. I know both parts are 7, so to figure out JL, it's 7 plus 7, which gives me 14. Next I need MN and MK. MK is the whole thing, MN is the part. However, where these are bisecting, these diagonals are bisecting here in the middle, right angles are formed. That means that I can use the Pythagorean theorem in order to figure out whatever leg or side is missing. So for this triangle down here, MNL, if I redrew it, I didn't draw it very well. There's my right angle, so here's my hypotenuse. Here is A. We need B. Whenever we need B, the shorthand equation is c squared minus a squared, all taken the square root of. So that means I'm saying 12 squared minus 7 squared, take the square root. If you were to put that in your calculator, that would give you 9.7. So that means M in this little section here, or B, was 9.7. Now in order to find the whole thing, remember it's just double, so I'm going to take 9.7 and add it with 9.7, and that would give me 19.4. My next one is pretty easy because there's a pattern that is formed. So I'm going to use two different colors. If you are a color learner, you like using colors to help you learn, this would help you also. Now if we were to flip back to our graphic organizer, the one at the beginning, the flow chart with the 4 quadrilaterals on it, I know that all of these angles that I'm making pink are the same because this bisects both of those angles and they are the same. So that means when I'm filling in this chart, all of the ones with the pink are going to equal 38. So if I were to go through this, 3 equals 38, 4 equals 38, and 5 equals 38. So I've got those pieces there. Now I need to figure out how to find the other 4 that are bisected. That's the ones that are in purple. Looks kind of black, but you get the idea. I know that this angle right here and this angle right here, so 3 and 38 added together and 7 and 6 added together, are going to be supplementary. They are going to equal 180 when I add them. Well, I know that pink side, where the 3 is, that both of those angles are 38. So to figure out the whole angle, I'm just going to add 38 and 38. That gives me 76 degrees. Now in order to figure out the other side, I'm just going to subtract that from 180. And that gives me 104. Now I know that that angle that is the 104 is cut in half perfectly. If I cut it in half perfectly, I'm going to divide this in half, and that is going to leave me with whatever the angle measure is. 104 degrees divided by 2 gives me 52 degrees. So everywhere I put a purple dot, that's going to be 52 degrees. So 1 is 52 degrees, 2 is 52 degrees, 6 is 52 degrees, and 7 is 52 degrees. Now I've got one last angle that is not accounted for. That's this one right here. That's 8. Now if I think back to when we did properties of triangles, a triangle is equal to 180 degrees. I now have both of the angles right here. 6 was 52. 5 was 38. So to figure out 8, I'm just going to subtract those two numbers from 180. So 180 minus 38 minus 52 leaves me with angle 8. If I were to put that in my calculator, that would give me 90. Now if I think back to the properties I used here, I know those internal angles right here where the two diagonals are perpendicular have to equal to 90. So that's another way that I could approach it if you didn't want to do that last step. But it's always good to check yourself to make sure you were doing it correctly. Now my very last one, that would be number 3. I'm going to go ahead and take a second and label what it gives me. ZY is 34, WY is 38, and angle ZXY, that's this one that I'm putting in orange, is 34 degrees. Now if I know ZY, or the outside, is 34, that means all of the rest of these have to be 34. I also know that WY excuse me, is 38. So if I need to figure out WV or VY, I'm going to take 38 and divide it in half. 38 divided in half gives me 19. So I know WV and VY are 19. I also know everywhere along this line, my angles are the same. So I'm just going to put an orange dot to represent that all of those are 34 degrees. Now I'm going to go see what I can fill in based on what I've got. I need WZ, that's this leg on the outside, 34. VY, that's this half right here that I already calculated, 19. I need ZV and ZX. I don't have either of those, so we're going to have to think through that. Now come to my angles, WXZ, that middle part, which is the angle we're looking at, has an orange dot. That means it's 34 degrees. WVZ is this middle angle. Now I know that middle angle because it's the property. I know everywhere has to be 90 degrees, so I know that has to be 90 degrees. Then I need ZYW. I don't have that one yet. And I need XYW. I don't have that one either. So I'm going to have to do some calculations now. To figure out ZV, which I can then use to double, I am going to have to do the Pythagorean theorem again. I've got leg A, my short side, and I've got my hypotenuse. So that means I'm following that same equation we used before, c squared minus a squared. I almost wrote the wrong number. It would make it 19 squared. Don't use the 34 like I almost just did. Once I type that in my calculator, let me type that in my calculator. That gives me an answer of 28.2. So here, I turned off the light. Here, ZV is 28.2. Remember, Pythagorean theorem, it's okay if you have decimals. If that half is 28.2, to figure out the whole thing, I'm going to take 28.2 times 2. And that gives me 56.4. Okay, my last thing is to figure out the angles. So I know all of the angles in a triangle have to equal to 180. I'm just going to start by finding one of them. I'm going to use XYW because it is in this triangle over here and I need it. So right now I'm going to say 180 minus 90 minus 34. Let's calculator that up and see what we've got. That gives me 56 degrees. So everywhere I just put a pink dot is 56 degrees. So we found this one, 56 degrees. Z, Y, W, 56 degrees. It's okay if it takes a little while for you to trace through to figure out. Remember, the middle letter is the vertex of your angle. However, it does matter the order because sometimes it might ask you for something different. Y could be this whole angle or just half of the angle. Move on to your practice. If you need help, please reach out for help. Good luck.